Okay, let's have a class and a little bit delay, but it's all scheduled. Everybody look at you. Antibiotic resistant plates. That is really good one. I like that one. Give it to me. This is a really good one. Okay, so I put on the camera also want people, if they don't attending class, can see. Really good. On the middle you see tetracycline, kanamycin, and chlamydia. Okay, so I want you to go ahead to measure it. Can you please measure it? So I'm gonna give you the ruler. Now make sure when you do these things. So I want to just give you an example. Let's say kanamycin, right here. Okay, measure using millimeter. So measure the diameter. Okay, like that. If you already measured, it's good. You go ahead and measure. And you can measure your own later on. So, let's talk about that. We had a monohalton agar. And then, we have a couple of discs there. So what you have is kanamycin, is that right? Is that kanamycin? So K30. That is K, which means kanamycin, and 30 is microgram. What is the diameter the inhibitor is on?
38 millimeters.
Okay. You will see this zone is 38 millimeter. So what you gonna do? Everybody look at your table. I don't have here kanamycin. Whether you can find it. I have one here. Let's see kanamycin, whether we can find here. Kanamycin. Okay, I have it. Kanamycin is right here. Okay. I'll left this table here. Kanamycin we see is resistant is less than 13 millimeter. Intermediate 14 to 17, and susceptible, which is more than 18 millimeter. So, what do you think of this bacteria? Which one is this? Did you label what is the bacteria?
Susceptible. Oh, this is E. coli.
Okay, so that is E. coli, let's say. Our inhibitory zone is 38 millimeter, which fits this category. So, what we said, we will say this E. coli is susceptible to 30 microgram per ml kanamycin. Okay? Can you go ahead to do this same thing and measure it? The table is right here. You can measure it. Okay. Let's give an example. Clayton, can you measure your sample? Can you measure one of them resistant? Tell me the name and which one looks like resistant. So we're gonna give you another example. Tell me what the other one.
Staphylococcus aureus.
Yeah.
And
E15, is that right? That's erythromycin. So erythromycin, we have to look at the table. Yes, is 15 microgram, and you see the inhibitory zone is very little. Is that right? Very, very little. So it's for Staphylococcus aureus. And what's going to be the erythromycin looks like? Let's look at the table. The erythromycin is resistant, intermediate, and susceptible. So resistant is less than 13. Intermediate is 14 to 22 millimeter, susceptible is more than 23. What is your results?
20.
Okay, pretty good. Then 20 millimeter, what this means? Which means this Staphylococcus aureus is intermediate to 15 microgram per ml. It's ppm, okay, 15 microgram erythromycin. Okay, we just write like that. So can the patient use this? No, of course not. It's intermediate. That's why we say this is a semi-quantitative test for antibiotic resistant. Okay, if you find something is resistant, you see some of your plates, let's say right here. This is a Staphylococcus aureus. When we see clam there, which is almost nothing there, which means obviously is resistant. Okay, this one is also a good one. Tetracycline, you see, really good. Tetracycline 30. Let's look at tetracycline 30. Tetracycline 30. It have to be if it's more than 90 millimeter, which means it's susceptible. I better say if you measure it, this will be more than 90 millimeters, so we can just measure it. Yeah, it's much more than that. It's like 20 millimeters, so we can say E. coli is susceptible to tetracycline 30. Okay, just give you an example how we handle these results, and you can. I would suggest you take a picture using one of E. coli and the Staphylococcus aureus as an example. Write on your notebooks, then you know what's going on. And this will be the table, the full table right here. And this is some typical table, which is I wrote on my textbook. Okay, just give you some example. Okay, what we're going to do today's work. Very bad modes. I made a sandwich to my son for his go to to the kindergarten. He left, didn't finish too much. Then I said, okay, I'll have it. We'll do the Eastern modes recognition in the lab. So what we are looking for? This is what we call pathogenic modes. Basically, you look at the picture. There is 3 different types. Okay, so we talk about here. Lab 17 pathogenic modes. Okay, we know that eukaryotes, which is fungi, have 2 categories, yeast and modes. Yeast basically 35 degrees Celsius, modes 25 degrees Celsius, which means room temperature. Now, basically what a fungi looks like. Fungi, there is a very fuzzy base. This is called a mycel. C-I-L-U, mycelium. And then you go here, like a spore comes out. Okay, that's called a cornidia. Like spore comes out. Then this spore will be released, go to the air, and you maybe inhaled it. Lots of the time cause lung disease, like a pulmonary disease, like histoplasmomycosis. It's in the Ohio River, Kentucky, West Virginia area, happened all the time. Lots of the times it's also come from the birds dropping. Okay, the fecal sample. So this is basically what it looks like. Now the fungi, how they generate a daughter cell? It's called a broad base body. That's the key how they generate a daughter cell. This is released like ovoid. So we call it like ovoid. And we know if we do a gram stain, it is all gram stain blue. So we don't say it's positive or negative. It is all gram stain blue. So today we wanted to see this molded bread. What type of pathogenic modes are they? Basically, we have 3 categories. It's on the first page. Aspergillus, penicillin, and the last one is Losapus. What it looks like, basically, which one? Now, how are we going to do it? There is a very simple method we can do, which is called lactophenol cotton blue stain. How simple it is. I will work with you because it's too molded. We have a glass slide. Now, of course, you write your initial name on the side. I'm going to add one big drop of lactophenol cotton blue. It's right here. One big drop on the slides. Then what I'm going to do? I'm going to using a tape. This will be a tape. Then I'll use a tape like this. Of course, you need to wear gloves to touch a very molded bread. You see something like this, something like a grayish color, something like a brownish color. Then you cover the surface. Okay, so this will be a tape. And then underneath 40x, this is the first time we use 40x and the only time we use 40x. We want to see what it looks like. Is that aspergillus, penicillin, or Losapus? Compared to the morphology on the first page, what it looks like. Okay? That's the first job. It will be two of you work together. The second thing what we're going to do is we want to find how many really molded molds or yeast is in this bread. I have a chopstick. I don't use bare hands, I use chopstick. And I have a sample bag. Okay, so very simple. I'm going to help you put the chopstick, grab approximately maybe 5 or 2 grams from each bread, put in the sample bag, and they are going to dump in 10 ml, a very limited amount of the nutrient broth. Then I'm going to go to the stomach to do the stomach. Okay, stomach about 15-30 seconds. So what we're going to do? This filter bag, we're going to have a 2 gram bread. So we're going to add 10 ml nutrient broth, and we're going to do stomach for 30 seconds. And through this filtered side, we will do a serial dilution. I only need you to do 2. Everything is 9.9 ml. 9.9 ml. So 0.1 ml go to the first one. 0.1 ml go to the second one. First one go to the second one. Then the same thing, we are adding 1.0 ml onto a petrofilm. This will be 10 to the 2 and 10 to the 4. Since we are adding 1.0 ml, this will be 10 to the 2, this will be 10 to the 4. Okay? And this will be storage at 22 degrees Celsius for 5 days. You may can count, you may cannot count. It really depends how bad is the bread looks like. So we will see. Okay, we will see how bad it is. This, because it's very molded, so we do a pair, which is 2 of you get 2 pieces and do a dilution, finish these 2 work. Now, there is a difference. What's the difference? This very molded bread needs to be plated on the petrofilm It's very similar to what I did for APC. But what's the difference? The pressure is different. Is larger, much larger. You have to use this pressure center. Otherwise, it will not be cover the surface. The results will be totally different. And luckily, I had 4 pressure. So every bench can use 1. I can only afford to buy 4. So there is a 4 for each bench. So it's very simple. 2 of you get 2 pieces. Come to the front. We'll prepare the molded sample for you. You go ahead to do the stomach, get the dilution tube, and then go ahead to do the plating. Okay? So I want to be just this is open a little bit, so somebody could come here. Then we'll still do the recording for you. So just pass away this side, not cover here. Then you can come here to get the sample. Okay, who wants to do the first? Yeah, the first sample, everybody just come here a little bit closer. Then I'll show you how we do it. Okay.
Also, I think these are extras. Do you want me to just like set them up here somewhere?
Sure. In this one. Okay. So we have this. The glove is too small. It's too small. Let me see. It's not good. Okay, how we do this sample? Tear it off. Like this. Okay, right here. This is very molded. What I do? Do you know how to use chopsticks? If you don't know, there is a instruction here. Okay, you know how to do it. Okay, we're gonna pick just a little bit because the whole bread have to be used the whole thing. Just pick a little bit. Okay, not too much. Put right here. Very sticky because it's molded. So I put them back. This is okay. Anyway, it's not going to be sterilized. Then what I do, I use a very smart way to do. That's about 10 ml. Okay, so we add it. Okay, then we put on the side. What we're going to do? We're going to go here to do a stomach. This is for the stomach. This machine is $2,000. Okay, that's good. This will be the first sample. Who wants to use it? First sample. Okay. Now, what we're gonna do the lactophenol cotton blue. Do you guys have a glass lights? Can I have 1 glass lights?
Yeah.
This needs to be done carefully because it's really bad. There's a cheese in the middle. Really bad. Look at this, so sticky it is. Look at this. Okay, very good. How we do it? Lactophenol cotton blue, we put 1 drop right in the middle, a big drop. It does need to be huge. Then what we do? You can come here to do it by yourself. Tape. Okay, now what we do? Try to your best to do like this. Then touch a little bit. It should be enough. Then we slightly touch a little bit too. We'll see what it is. Okay, that's enough. Then we cover it. Be careful. This needs to be a little bit tricky. That's all. Underneath 40x, do your observation. No oil immersion. This is not gonna work. Okay, we'll see what it is. Is that aspergillus, penicillin, or lutopus? This one you have to do a dilution, which is 10 to 0.1 go 9.9, 0.1 go 9.9. We plated on the petrofilm. Okay, so these 2 will be given to you, and this will be given to you. You guys could share the whole bench. This will be your slides. Okay, that's the first one. Okay, we'll do these one by one. Is that okay? So let me turn off the camera first. Then we can go ahead to do these one by one.